Hey everyone, welcome back. We are doing our June 2026 production update. We've got a lot of news to talk about. First of all, I think I've pretty much mentioned this every single month for the last couple months, but we have a lot of positions open here at the company. So I am imploring people to apply to work here. We didn't have a lot of positions open, I think, in the last couple months, but we've slowly been adding them to our Indeed. Right now, I believe we have position for content creation, videography. We're looking for someone to help with the Sienci instruction. We want to get more people into learning how to make stuff with their CNC machines. We're opening up more engineering positions. I don't think they're been posted yet, but probably by the time this video goes out, we'll have more engineering positions. We're looking for someone for continual improvement, for firmware development. We also have a lot of new development coming out for gsender. You can check it out on our blog. We have links there, or on our website, or just Google search CNC Labs careers. We also have a general application form. So if you don't see that position up yet, you can submit your resume. Next up, we are working on a lot of new changes to our website. Behind the scenes, Jason, who leads our customer service team, he's worked a lot on trying to automate and aggregate all the help and information that we've been providing with our customers to solve technical issues. You've probably seen new videos come out for solving alarms, solving basic issues on our YouTube. And one of the other things that we're working on, because we also brought on a new web developer, is to revamp a lot of the sides on the customer service facing aspect. So that's changes to our contact us page. We can be a little bit more detailed on getting people to the right people. Yeah, we have quite a lot of people helping, just dedicated to helping our customers. We'll see changes to the website coming up, primarily focused on the customer support side, and eventually we'll be revamping a lot of things with the ordering, being able to track your orders. I think the way that we're tracking orders right now is a little bit primitive. So if you checked out the order status page, we've been updating that with the Google Sheets on a weekly-ish basis. We'll have some changes to that and so on and so forth, rolling down in the next couple months. So big news for this month, because it's May 26th, the time of our filming, is the launch of the Longmill Mark III. So if you guys don't know, we've been building the Longmill lineup for a really long time now. I think we have more than 10,000 Longmills out in the world. And through that, we've learned a lot of things. We've also built quite a lot, thousands of altmills at this point. So we've aggregated everything that we learned from the Longmill and the altmill. We've combined those technologies to build a successor to the Longmill Mark III, and that's launched today. Oh, we sold 7 in the first 6 minutes. If you want to learn more about it, we have an article, everything that you need to know about the Longmill Mark III, that basically covers our engineering philosophy, the pricing, the production timelines, all of those things. So if you're in the market for an entry-level CNC machine, check that out. It's on our blog. Currently, we are in the production for the first 1,000 units. We're expecting to ship the first 300 in September. The last final parts of development include the design and testing for our packaging. Nikila, one of our engineers, has been working tirelessly on that. So we've kind of established the design of the packaging, and then we're doing different configurations for the foam to hold everything together. We've been working on the SLB and SLB EXT version 2 and SLB Lite, which will be the successor boards for this generation of machines, which is basically commodified, lower cost, but same functionality versions of our SLB line, which is running Gerbil HAL. We also are continually doing machine testing. We also have beta testers that are actively doing testing as well. And we are also launching a new version of the Longmill Mark III dust shoe. So that'll be a simplified version. One key thing is that it'll be much cheaper than the old dust shoe, and just a different style. Those will be backwards compatible with other Longmills if people want to try out those dust shoes. So one of the things that we mentioned in our previous updates was that the SLB Lite, which is the board that will be used in the new machines, those are kind of our final part of the whole ecosystem. The long mill's electronics make up a really large portion of the total cost for us to build a machine. Because the original SLBs were pretty expensive to make, we've basically made a streamlined version of the SLB called the SLB Lite, specifically designed for the long mill lineup. And so those electronics will cost half as much as the outgoing versions of the controllers while still preserving the functionality. The other thing to add is that one of the key things that people wanted to have is 220 volt support, especially for a European market. The new versions of the boards will be using power supplies that are multi-voltage compatible. So regardless of whether you're in North America, Canada, US, so on and so forth, using 110, 120 volt, or if you're using 220, 240 volt in Europe and other markets, now you don't need a transformer, which is awesome. So we are doing testing for the new power supplies and the controllers and so on and so forth. We have the new prototypes come in. We've been testing the crap out of them. And with anticipation of the production of the new boards, I believe we have the first couple hundred in production now. We will get those batch in August-ish, I think. We also have started production for all the packaging material and the cases. We got first samples of the control boxes, which is pretty exciting. The form factor of the new controllers are also more compact, so it'll save on the shipping cost as well. Size changes and the advancement in the firmware and the hardware is incredible. That's happened in the last couple of years. Yeah, we're also in production of all the metal backing parts, so like the case components and stuff like that. So those will be coming in probably in the next month or two. The altmill 4x8 we've been shipping since last month. I believe we shipped the first batch, 80, 90-ish machines. We're in production for the next 300 machines, which will be arriving, I believe, in August. We have been doing a lot of continual wear testing for the machines. One of the tests that we've done is to move it basically back and forth 100,000 times at a high speed and acceleration, so which is way beyond what would be typical for the average users to use. And we did learn a couple of things. One is that the backlash has remained pretty much the same through the whole abuse cycle, so under 2007 inch. We've been able to get the motors to heat up to about 92 Celsius, pretty much at the level of the 90 Celsius limit that the gearboxes can handle. And we did find that the bearing retaining rings do come loose over time, and the remaining components are secured to the torque specs that we need them to be. Under normal operating conditions, we should basically see no performance decline. The motors will heat up to the limit of what we have engineered the gearboxes to, but those will be at the most absolute extreme conditions. Because there is a risk for the bearing retaining ring to come loose over time, we've implemented Loctite for that assembly. However, the test conditions that we're running the machine at is like so far beyond what would be normal operating conditions. One, it's unlikely that the bearing rings will come loose over time for pretty much any user existing right now. The other good thing is that it's very obvious to tell when those rings do come loose, and so if we do need to address them, they're easy to tighten and address. You know, we're talking about cycles that may happen in a year or a couple years. So we have done a lot of due diligence in the engineering prior to launch, and we've continued to do that, and we will monitor and address issues as they come forward. But yeah, overall, the wear testing has been relatively successful. A lot of people have been asking about the clear-cut dust shoe. We did launch this a couple months ago, and we basically sold out of our first batch of individual unit sales, so dust shoes not included with spindle kits. We'll have a bunch coming in soon, so I believe we'll have orders opened up for those. But yeah, the large majority of those will be showing up here in August. Spindle lead times have been long for last couple months, but we did receive a new batch, so the lead times for the spindle kits have come down a lot. Today we've cleared out of the backlog, so we'll be shipping out until we run out of spindles again. Check out the product listings and the order status pages to see the latest updates on the spindle kits. We got a lot more orders for the 1.5 kilowatt spindle kits, which is the ones that were backlogged, more than we were anticipating, so we didn't order more on time. But we've obviously will be adjusting for the demand. As we're wrapping up some of these major products like the longmill Mark III and the altmill 4x8, we've slowly been and the ATC, we've been slowly transitioning to kind of trying out some new stuff, and we have kind of some proof of concept things going on. Some of these projects have been dabbled in for the last couple months. Some of them are more recent. The idea is if we share them to the public, maybe we'll get some demand or feedback on if they would like to see these type of things. Our company, Sienci Labs, is very dedicated to R&D. We aim to be at the forefront of hobby CNC development in all aspects: software, hardware, electronics, so on and so forth, as well as keeping the costs as low as possible to make the technology more accessible. And so, yeah, just a reminder that if you support us by purchasing our stuff, then that money is going to go a lot into the R&D side of things. So first thing that I think is really cool is the auto feed rate feature that Johan had been playing around with. So just for some context, traditionally when you're running a CNC machine, you would program how fast and how deep the machine cuts, or as a lot of us refer to it, the feeds and speeds. The machine, if it could cut faster, you would have to kind of eyeball how much faster you're doing it by just like adjusting the speeds while it's cutting through the speed, like feed rate override functions. The other part of it is that there's some like guesswork involved in choosing the right feed rates. And you also have to have a threshold where if you're cutting through a particularly difficult part of the material, that you have enough headroom for the machine to cut through it, because it's very difficult to program the tool paths to have variable speeds along the cutting. With the implementation of auto feed rate, we can measure the power draw of different components within the machine, so the motors and the spindle. And so if we see that there is enough headroom for the machine to cut faster, we can adjust how fast the machine cuts on the fly. So let's say, for example, and there's a video of this to showcase this on our blog. Let's say you're cutting through a really thick piece of material and there's a knot in it. Then as the machine hits that knot, it can slow down so that the load on the spindle stays constant. Or if you're cutting through softer materials and you program your feed rate really low, if the machine knows that it's got a lot more power that it can give through cutting the material, then it can automatically adjust the feed rate to be higher. There's a lot of programming and testing involved in this type of application, but the thing that's really exciting about this is that the cost of the hardware itself is pretty low to be able to implement this feature, and it eliminates one of the largest challenges that comes with programming for CNCs. So essentially the way that it works is that there's a current sensor that detects the flow of current to all of the motors. And based on the flow of that current, we can extrapolate how much load is being placed on that motor and automatically adjust the feeds and speeds, because we obviously can control the speeds and the speed of the motor and the speed of the spindle on the fly. The release of the Auto Spin T1, which is the entry-level $150 router that you can control the speeds on the fly, we can bring this feature to the entry-level market. This is a feature that does exist on the higher-end machine market, but typically will cost tens of thousands of dollars to implement. Pretty crazy to be like, oh, we're gonna take this $30,000 feature and make it cost like less than $100. So there's a lot of moving components to this type of development because it's very, in a way, theoretical, and also requires the collaboration of our hardware and software engineers. It's pretty exciting to see this type of stuff because it puts us really at the forefront of this industry. The other project that's been going on over the last couple of months, but kind of rolling into more earnest, especially with the launch of the Gerbil 1.6.0, which has been our most successful launch for gsender to date, with key feature updates like 50% faster loading, I think, or 90% faster loading. I don't remember how much faster it is. It's just way much faster. The implementation of the ATC functions, the G-code editor. There's like a billion things. I don't remember all of them. Check out our blog. We have another blog that we are putting out regularly for gsender updates now, and the software is free. So you get all this for free. Like, we're the best, basically. But one of the things that we have tried to address with running gsender is the cost of the computing hardware that it needs to run on. Traditionally, we want to keep the cost of the whole system low by allowing people to use like their own laptop or computer, which a lot of people have on hand, to just run on like typical Mac or Windows or Linux software. The systems are only as reliable as the computers that people provide them. So it's a really good low-cost option for the hobbyist market, but it does come with the drawback of, it's just less reliable. We built and started selling the G-Control panel computers to address this issue halfway. So we have like a Windows IoT with like an industrial version of Windows that is more reliable than off-the-shelf Windows that you would find in typical computers. And obviously we do the testing to make sure that the panel computers are compatible, but they are really expensive. And we found that a lot of altmill customers will buy them, but very few longmill customers, which is kind of our budget segment, will buy them. We wanted to find a way to provide the computing hardware at a cost low enough that either the altmill or longmill segments can afford. One of the things that you'll see coming down the line is a new revamp to the UI, which runs better with touchscreen. Traditionally, gsender was developed more for like traditional mouse interface, but as we've seen, the market is going more to the touchscreen side, and I think that makes sense because there's so many features for G-code sending softwares that it's hard to put all the buttons physically. Kevin showed me a very early version of the proof of concept that can run on CM4, which is like a low-powered compute module for Raspberry Pi. That will kind of bring us to a path where gsender can run on very low-powered hardware, which will also mean that the cost of the hardware to run the machines can come down significantly as well. As we go into the new version of gsender, we'll likely see more improvements on the optimization side, as well as we are working on developing a new pendant / like tablet type device that will be plug and play used with our machines. It has the same function as the G-Control panel computer, just at a lower cost, and it won't be running like Windows and stuff, so it'll be more of an integrated system. And the idea is that it'll be more reliable and more streamlined in the operation of the device. So these things, we are working on them, have meetings set up, planning to be done. So there are more continual improvement projects, but I don't know, maybe in the next couple of months, we'll see some new things come out. Oh, I also wrote, like, just for context, like a CM4 will cost like anywhere between $30 to $100 versus like a G-Control panel computer is like $400 to $600, I think. It's funny because I was talking with Liz, who's one of our project, well, we will have a conversation about this. Liz, who is one of our project managers, about keeping track of all this development stuff, because now the company's gotten so large that now I can't keep track of all the development that's going on. So we'll see how the format of the production updates will go as things go along. But yeah, otherwise, if I miss something, I guess wait till next month. Or just keep checking out our blog, or keep checking out our YouTube videos, and our social medias, and our emails, and all those things. There's so much things going on. It's pretty exciting. I guess we'll see you in June, July. See you later.